everyone, a very good day to all of you. So today we are going to explore an interesting and visually engaging experiment under thermodynamics. So our experiment is the dance of hot air exploring the convection current with a paper spiral. And in our experiment, we'll observe how a spiral-shaped paper spins when placed above a flame. This motion happens without any physical contact, only due to the invisible rising of the hot air. So this will directly demonstrate how heat affects the density of air, leading to movement and convection. So we are trying to achieve certain objectives from this experiment. The first one is understand the concept of thermal convection in gas and relate air movement to change in density caused by heating. Identify similar real-life examples of convection, and last but not least, develop our observation and interpretation skills in physical science. So let's begin and watch how a simple spiral paper can help us visualize the powerful and dynamic behavior of a hot air. So stay tuned.
In the simple setup, we're going to see some powerful physics in action. We'll see how heat causes air to move, how rising hot air creates convection current, and how invisible air pushes something as light as a paper into motion, all explained by the laws of thermodynamics, density, and energy transformation. Watch closely.
All you need is a paper, scissors, a candle, and a stick.
Step 1. Draw a spiral on paper, like a snail shell, but don't fall asleep halfway. Start from about 3 cm in the center and go up to 10 cm. Now, fit a stick upright with some clay. Gently place the spiral on top so it can spin freely.
Next, light the candles and place it below the spiral, not too close, about 5 to 10 centimeters. We are spinning it, not setting it on fire.
Watch closely. The spiral should start spinning within a minute, slowly at first, then pitch up speed. When the flame hits the surrounding air, and here where the convection begins. According to the principle of convection, when a fluid, in this case air, is heated, it adds mass. So this makes it less dense, hence it rises. 3.
As hot air rises, it creates an upward flow, forming a convection current. This invisible stream of air pushes on the spiral, transforming energy, causes it to spin.
Now, for set B, 4 candles, twice the heat, twice the drama.
And yet, the spiral spins way faster. It also reacts quicker to the heat.
So, what did we learn? Set A, 2 candles, steady spin, takes a bit of time. Set B, 4 candles, faster spin, quicker start.
More heat equals to stronger convection, meaning it more motion. It's simple but super cool.
You are probably wondering what's really happening. You are seeing the first law of thermodynamics, where the definition is energy cannot be created or destroyed, only transformed. Here, chemical energy from the candle transforms into thermal energy, which heats the air and finally becomes kinetic energy, the rotational motion of the spiral. Now let's talk about torque, the force that causes the object to rotate. Because if you notice, the spiral isn't flat, it has a curve. The rising air doesn't just push up, instead it's also pushed sideways, causing a rotational force. Experience convection current in your daily life. A very good example would be sea breeze, where cool ocean air replaces hot rising air from the land. Other than that, radiators, it wants room by moving air. And last up, we also have hot air balloons, literally floating on the principle of convection.
Experiment, we saw that the spiral paper spin faster when more heat was applied. This shows the rising hot air caused by heat can create movement. It demonstrates the concept of convection, where the rising hot air carried the energy upwards, pushing against the spiral and causing it to spin, then turning the thermal energy into motion.